Hey guys, and welcome back to a new video. In this video, I will show you how you can make use of annotation classes, or rather just annotations in Kotlin. So we all know these, that we can annotate our stuff with these existing annotations. Like, for example, if we have a test case, we do have the test annotation, which is only accessible in the test sourced. But that basically tells JUnit in this case that the function we're annotating this with is a test case. And there are a lot of these predefined annotations, but how can we actually make use of these and create our own ones, and then also tell our functions and our classes, our fields, that if an annotation that we created is added there, that we want to do something specific. So in this video you will learn how, and I want to start with a more theoretical example, so you just get to know annotation classes a little bit more and how we can work with these, how we can process these, and then I will get to a more practical example that shows you how you can actually use these in your Android projects in a very useful way. So let's assume we do have something like a data class called user. Each user has a name, and let's say each user has a birth date. Then we can do it like this, but since the birth date is actually a string here, but can actually only take a certain format of date, so we actually only want to be able to pass dates here as a string and not any other kind of string, for example, like a name. So what we could do here is we could use an annotation to enforce this. And to create this annotation, that we can basically define some kind of regular expression, so regex expression, that this specific field must fulfill, and if not, that we simply throw an exception. So we can achieve this by creating an annotation class. That is how we define our own annotation, and we can call this, for example, like allowed regex. And we can then give this a constructor just like any other class, and we can say we pass the regex here as a string that we want a certain field to fulfill, to kind of fit to. However, this right now won't really work, because if we define such an annotation class, then we again need to make use of annotations to kind of first of all define where we can use this annotation, how it's kind of processed and things like that. And there are multiple common annotations we use for annotation classes to define exactly that. On the one hand, that is target. So add target, and here we need to specify what we kind of want to be able to add this annotation for. So we can say annotation target, and you can see we have function, field, class, annotation class. So a lot of these targets that let us define that, okay, this annotation is actually only applicable to functions. If we want that, then we can define that here. And you can see that as a var arg, so you can, of course, define multiple of these targets. If you want your annotation, for example, to be applicable to classes and functions, you simply add these two here. And in our case, we want this to be applicable to fields. Since we want to add this to our birth date, which is just a field of our class, could also just be a member variable or so. So we just add that here. Then some other common annotations we can use for annotation classes is, on the one hand, must be documented. That basically just means, if we take a look at the documentation here, that this annotation that we define here, so our allowed regex annotation, will also be included in the public API. So if you generate some kind of documentation for your source code and you have this annotation for your annotation class, then your annotation will also be contained in the generated documentation for your code. Let's remove that and take a look at the retention annotation, which is also commonly used. Here we need to specify this annotation retention. You can see the annotation retention. You can see the default is runtime. So what can we actually define with that? With this annotation retention, we basically define where and when this annotation is actually accessible. Usually you can leave this at the default runtime, which means this annotation is kind of baked into the final binary file, so your APK file, or rather your jar file later on, and it is also accessible via reflection in your code. Then we have source, which means it is only accessible via reflection, but it is not contained in the binary anymore. So you can pick that if you really don't need to kind of process this annotation after you've actually already built, or rather generated, your binary file. And then we do have the binary retention, which means that we cannot access our annotation with reflection in our code. However, it is baked into the binary file. This is, for example, used for the program annotation, which is keep. So that is basically just an annotation that tells us, hey, or that tells Prograd, hey, please don't obfuscate this class we annotate this with. And since Prograd operates on the final jar file and it's not kind of part of our source code, this annotation needs to be accessible in the final binary file. That would be one use case, for example, for the binary retention. Just to give you some kind of examples, you can imagine what that could be used for. And one last annotation that we can commonly use for annotation classes is add repeatable, and that should be self-explanatory. That basically says that if we have this annotation for our annotation class, then we can repeat the annotation multiple times for the same field. So in this case, this doesn't make any sense, but sometimes, it would make sense, and then you can use this annotation to define that you want this behavior. Let's remove that again and just keep this target to make it applicable to fields. And now the next step is if we annotate our birth date with our allowed regex annotation now and pass some kind of regex like this, for example. So this is a very, very simplified regex for dates, but it basically just expects 4 digits at the start, then a dash, so that will be for the year, then the second number here, it expects 2 digits for the month, dash again, and then 2 more digits for the day. So we can now add this annotation to our field. You can also see if we would add that here to our class with some kind of empty string, it wouldn't work because we did not add this class as an annotation target. If we would want that, we could add that here like this, and then you can see the error is actually gone. But in this case, it wouldn't make any sense, so we leave it like that. How can we now actually process this annotation? Because right now we did not define the behavior that we actually want, that we throw an exception if this regular expression is not met in this certain field here. And we do need to process that in the class here where we actually add this. If you use that at multiple places in your code, then you could also use some kind of helper function or so, which you can then easily just reuse in different classes. But let's keep it simple here and just have our init block in which we want to verify that this regex is met. And here we can now say we refer to the fields, which is this. So we refer to our user class, ;class.java.declared fields. With that, we basically get a list of all the fields this user class has. We can then use that to loop over it, get a reference to each field, like this. So this will now be looped over name and birth date, and then for each field, that could contain multiple annotations. So we also want to loop over that. So for each annotation, we can now actually check if the field contains a specific annotation, like in our case, our allowed regex annotation. So we can say if field that is annotation present. Here we can pass the annotation type, which is in this case allowed regex ;class Java. If that's the case, we know that the field we're currently looping over has our allowed regex annotation. So if we know that we added this annotation, we now need to verify, or we now need to retrieve this regular expression of that, and then check if our birth date is actually matching that expression. And to do that, we first of all need access to this regex variable here. We can do this with val regex, and that is equal to our field .get annotation to just get a reference to that annotation we're dealing with. We need to pass the type of that annotation, which is allowed regex ;class Java, and now we get a reference to that. We can add .regex, which is now referring to exactly that variable, and then we can check if our regex .toRegex, so we actually get a regex object we can use to match a certain string, and then we can say .matches our birth date in this case. If you would have this annotation for multiple fields in your class, you would also need to kind of check if you're actually dealing with your birth date field here. But in this case, let's keep it simple and just always assume that if we have this annotation, we're dealing with this birth date. If that is false, that means the regular expression is not met for our date string, then we simply want to throw an exception. In this case, something like an illegal argument exception, and we can say birth date is not a valid date. And then we can, just print the date like this. And of course, in this case, you could also simply not use an annotation here. So you don't have to use it to achieve this kind of behavior. You could also as well just have an init block and then check if the birth date is a valid date. And you could also make a helper function for that to validate that with your regular expression or so. But yeah, that was rather just to demonstrate how we can use regular expressions in our code. And in pretty much all scenarios, you don't have to use these. These can make your life easier, but it's not like you can do things with these annotations you can't do with other things, at least not in this normal context. If you write a library that generates a lot of code, then you often need these annotations. For example, if you're dealing with a room library, the authors of that, of course, need to kind of define if a class is annotated with a database that you generate a certain piece of code for that. That is a scenario where you have to use annotations, but usually if you just have your kind of app and you don't write a library to generate code, then there are also usually ways to solve your problem without an annotation, but these can make your life easier. So now that we understand how annotations work, let's get to a more practical example. And if you're an Android developer, I'm sure you know retrofit, and that is why I already added the dependencies here to show an example when using retrofit here. So I added these dependencies, make sure to add these as well if you want to follow. And what I basically want to show you here is if you have some kind of remote API you're dealing with, you're using retrofit, and there's certain routes which are simply not authenticated, so which might not need an attached token, and there are routes which do need that. Then I will show you now how we can actually create an annotation that we can add to our retrofit API call functions if a certain route is authenticated, and then we create an interceptor which will automatically attach a certain token if that annotation is present. So let's start one step at a time, and we go to our root package and create a class like myAPI. There won't be anything very functional. We just want to have some kind of practical environment here. And I will use the JSON placeholder API for that, which is just a pre-public API to experiment with APIs. First of all, I want to have a suspend function to get a user. And here we simply have a get request to /users, and we refer to the first user. Then we want to have another suspend function to get a post. Here we have a get request to /post/1. And let's now assume that this get user function does not need authentication, so you don't need to attach a token for that. But this get post function does need that. So in a real life context, that could, for example, be a login function where you don't need to attach a token because you need to log in to get your token. And it could be something like a function that gets your current profile, which you of course need a token for. Otherwise, anybody could retrieve your profile data. So let's now go ahead and create an annotation class here, which we call authenticated. And if that annotation is now present at such a function, we want to add our token to our request. So we say the annotation, actually the target, is annotation target, and in this case we want to be able to add this to functions. And we say the get post route is authenticated. So here we do want to attach a token. Then how can we now check if this annotation is present and actually attach the token if it is present? So let's go ahead and create an auth interceptor. An interceptor is basically just something that will run on every single request your API client makes, and then kind of modify your request, because that is what we want to be able to do here. We want to add a header if that annotation is actually present. So that is an interceptor. We need to override the intercept function, and here we just get a reference to the chain which contains our request, and we can return a response which is basically the modified request. And the way we do this with retrofit is a little bit special. We need to first of all get a reference to this invocation. You can see this comes from retrofit, and this is basically just a function invocation. So the function that we actually call here where we added this annotation. And we do get this by saying is equal to chain.request.tag, and here we say we tag this with an invocation :class Java. If that's null, so if that's not existent, then we simply want to return chain.proceed, so we simply proceed with the request that is already contained in the chain. So we don't modify it at all. And now with this invocation reference here, we can now have a variable, a boolean, should attach auth header, and that is equal to invocation dot method, to refer to the method of that invocation, since that is where we added this annotation. And here we now have the option to actually access the annotations, and we can check if we actually have any annotation where id annotation class is actually equal to our authenticated annotation. So this is really just a special way how we do this with kind of retrofit, because we don't really have access to the class where we added this annotation here for, or rather a reference to the API interface and that we add this auth interceptor for. So we need to do it this way. It's just what you need to do if you want to do this with retrofit. Then we can check if our should attach auth header boolean is true, then we want to return chain.proceed. So we proceed with a modified request in this case, and we can say chain.request.newBuilder to be able to modify it, and we want to add a header. In this case, we want to add an authorization header, and the value of that is, yeah, just let's say my token. Of course, in a real app, you would attach a real token here. Then we can say that build, and else, if that's not the case, we simply proceed with the initial request unmodified, like this. And this will now run for every single request we make with our API client, and then just check if this annotation is present for that certain function, and if so, it will attach this token. So let's try this out. First of all, going to manifest and adding the internet permission, users permission, internet, and then going to main activity and scrolling up. Let's just initialize our API client here, private val API by lazy, like this. And here we can say retrofit.builder. We set the base URL to this. So that is the API we'll actually use to make our requests to, just that we have some kind of valid data. Then we want to add a client, which is an OKHTTP client, where we need to add these interceptors. So here we can say, okay, HTTP client dot builder. We want to say we want to add an interceptor, which is in this case our auth interceptor. We then want to add another interceptor, which is our OKHTTP logging it's just HTTP logging interceptor. That is the dependency I actually added here, HTTP logging. That is the dependency here, which basically just logs our whole request. So the JSON response, JSON request, all the headers, so that we can just see that the header is really attached. So let's create that here, and we set the log level to body, like this. And then we can say that build. We want to add a converter factory just for JSON converting, which is Moshi converter factory.create. And then we can say that build dot create, and want to create our my API like this. Cool. Let's first of all try our user regex here, or user class. If we create a user here that is equal to a new user, then we say the name is, I don't know, Peter, and the birth date is something like 18/4. It's actually the other way around. This, let's say 2002, and this would be our date. Let's make it a valid date here, like this. Well, let's actually start with an invalid date. Let's add a letter here, which would then not fulfill our regex. If we then launch this here on our device, then we should actually see that if this app is launched, we get a log for that exception that we throw here. So this illegal argument exception. If we take a look here, now it's launching, and you can see we actually do get it here. Oops, what did I do here? Our birth date is not a valid date, and here it actually prints our date. If we remove this H here, so it is a valid date, we relaunch this, then we should not actually get an exception this time. So if we take a look here, scroll down, there is no exception. So that is working perfectly fine. Let's try the our other thing we did here with retrofit by actually saying, okay, lifecycle scope, launch a curtain here, And here we simply want to say our API get post and API.get user to just have calls to this, launch this app, and then in here in our logcat we can actually filter for OKHTTP to get the logs. You can see for our user function, which is not authenticated, we did not add the annotation here. We actually don't have the header for our token, so there is no authorized header in here. But if we scroll up to our other call to posts, and we take a look here, here it is. Here's our authorization header with our my token because we added the annotation here. So that is a very cool way now how you can actually add certain tokens in your project. And if you have a large project, this is really a really good way to actually do that if that logic kind of differs for different routes. So I hope this actually helped you to understand how annotations and annotation classes work, how you can process these and just use in your project to make your code a little bit cleaner. If so, you will definitely also love my premium courses, which are more advanced and prepare you to become an industry-ready Android developer. If that sounds cool to you, check the first link in this video's description. And apart from that, I wish you an amazing rest of your week and see you back in the next video. Bye bye.